Welcome. My name is Austin Johns. My partner's name is Bailey Deal. And today, I'm going to be talking about the effects of temperature on water quality. So let's get into it. There are basically two major groups of causes, that is man-made and natural. We'll talk about man-made in a second. But natural includes sunlight and atmosphere. Sunlight basically heats the water directly, and atmosphere would heat the water by being adjacent to it. So just being near the water, the atmosphere heats it slightly. Other two are turbidity and confluence. Turbidity is basically suspended particles in the water, and since they are darker color than the water, they absorb more wavelengths of light, heating the water faster. Confluence is different temperature water flowing into a body of water. So glacial flows, streams can be confluents, and also hot springs. Man-made sources of water are normally referred to as thermal pollution. Examples of this can be industrial heat waste, like steel mills or apartment complexes or what have you. Runoff, which refers to, it can refer to a lot of things. It can refer to runoff from farms, runoff from cities, just basically any sort of runoff from a man-made thing that changes the temperature of the water. Deforestation is obviously the cutting down of trees. Deforestation is removing the shade that would normally go to things like streams, and thus the sunlight heats up the streams faster. Other things are impoundments. Impoundments is dams and other things that change the flow of the water. On the right here you see a nice graph displaying the temperature before and after a dam. But basically they change the temperature of the water by going through or around the dams. Consequences. There are consequences on behavior and biological functions. Basically, some species rely on temperature to tell when to do certain actions, like migration or resting, and sometimes it can affect a predator-prey response. So changing the temperature of the water can make them do this at random times or times that they're not supposed to. Metabolic biological functions. It can quicken a metabolic rate, which can be harmful to an animal. It can deter enzymes, and in some cases it can inhibit photosynthesis, which would also lower the dissolved oxygen content of the water, which can harm plants and animals. Here it is again with decreasing the dissolved oxygen content. These are the consequences of increasing water toxicity and decreasing dissolved oxygen content. On the right here we have a graph on how the increase of temperature can increase the solubility of salt. The toxicity is with warmer waters, heavy metals can dissolve quicker, and heavy metals in low concentrations are toxic, which can harm plants and animals in the water, and less dissolved oxygen can mean that there's less oxygen in the water to go around for plants and animals to absorb to get their nutrients. Management and mitigation. Restrictions on mitigation. It mostly has to be man-made sources. It's very difficult to turn off the sun, and so we really have to focus on things that we've done. You could put restrictions on hot flows flowing into streams, or you can't really restrict glacial flows, but it's just so hard and unnecessary that we really have to focus on man-made sources. Other things or solutions are problem-oriented. This basically refers to that there's no real cure-all for pollution like this. You have to look at the problem, look at what's causing it, and then fix that. Examples of places where we tried to fix it are nuclear power, dams, and agriculture. The mitigating features that we use in nuclear power basically come down to two. That's the primary and secondary water system and the cooling tower. Now, the primary and secondary water system is what's referring to this right here. And I'm not going to explain all of it, but I'll try. The basically the water that comes from your water source, like Lake Harris is an example, and I believe this is a picture of Lake Harris, or of the Sharon Harris Power Plant, which pulls from Lake Harris. Examples pulling from a water source, that water that comes from the lake or the stream is not the water that touches the nuclear rods. It's a different set of water. So this water, the one in white, is the one that actually goes and touches nuclear rods, and this one in blue is the natural water. So when they pump the natural water through, all it does is cool down the main one, and they are in adjacent pipes. So they don't ever touch each other. And so none of the nuclear waste is transferred, and more important for this specific type of pollution, they don't heat up as much. Because when you go through the nuclear rods, it comes out superheated, which is how it can spin a steam turbine. All this does is cool it down a little bit before it goes back in. So this does not get nearly as heated. The second, and probably the most recognizable from a nuclear power plant, is the cooling tower, which is this thing, which I'm sure you've seen from Sharon Harris if you've been by that way. It is huge. But basically, this has nothing to do with the power itself. It just cools the water. So when the water comes out of cooling this other set of water, it just goes up into this little smokestack here. And these are just pipes that go back and forth like that, up and down the tower. And it just uses the air around it to cool the water going through it. So this tower is actually hollow, and as is all of them in real life. And all of this little smoke coming out the top is white, which means it's steam. So that is just steam coming out of the top from the water cooling down. That way, when it goes back to the water source, hopefully, it is as cool as we can make it. Dams have tried something recently called hypolimnetic aeration. Hypolimnetic aeration is not a recent thing, but they have tried to apply it into newer dams. This is an older dam in North Carolina, so I don't know if this one has it, but that is a local dam. Hypolimnetic aeration is basically what you put. It's like the tiny machine that you put in your goldfish tank so your goldfish can survive for like a day or two longer. It's that thing. So this is a example of a larger version of that. It just pumps oxygen into the water, increasing dissolved oxygen content. And basically what this does for a larger dam, what this does for a goldfish is makes it live longer because it has more oxygen in the water to consume. What it does for a larger dam is a higher dissolved oxygen content means the sediments will fall faster to the bottom. And sediments going to the bottom, as we talked earlier, sediments can heat up water, so sediments going to the bottom will keep the water at its normal temperature. So they've tried using devices like this downstream from a dam or stuff inside of the dam to aerate the water and up the dissolved oxygen content. Third and final is pesticides in agriculture. Mitigating features are normally self-mitigation. Basically, the thing about this is that pesticides are normally used by farmers who it's just up to them. So self-mitigation is just it's individuals having to think, oh, I should use this different type of pesticide, or you should use less pesticides, or try an alternative. There are things that you can do to self-mitigate. If you have a small enough field, there's certain plants that will get rid of pests in the same way. I know mint leaf is one of the examples of that. But on larger fields, there are less harmful pesticides they can use. Ones that don't include certain chemicals, but they are a little bit more expensive, and so we've got a long way to go on that. Basically, here are our sources. There's 3 of them. I hope you had a good time. Hope you learned something. Enjoyed yourself. Have a wonderful day, and keep learning.